Hello guys, welcome to my YouTube channel. Today I'm going to explain what is about recursion and memoization in Java. Uh, so uh, this video is a part of the challenge in the uh, Telescope YouTube channel. This way now whatever the thing we are going to teach is based on the things what we learn from this daily live sessions on Telescope. So yes, you can also participate in this live context. This will be daily, like up to 10 days. So we'll be learning somewhat new in this Java. So today I'm going to tell you something about recursion and memoization. Okay, let me share my screen. Okay, yes. Okay, now first, what is recursion? So recursion is nothing but calling a function by the same function. Calling calling a function by the same function. So what exactly recursion means? Calling a function by the same function. So let me show an example for you. Let me open my Visual Studio Code. So if you see this factorial code, so which I have written. So here actually I'm calling. See, actually a fact of num is an separate function, and in the function, and in the function, what I am returning is returning num into factorial of num minus 1. So see here. In this like line number 14 to 22 exactly explains what factor sorry like what recursion means. See, calling a function again in the function, calling a function in the function, calling a factorial of num minus 1 in the factorial of in num function. Yes, this exactly means this exactly uh, explains about this recursion. Yes, why do we use recursion means to reduce the number of lines of code. I'll explain how it reduces the code, and also how it works in the several cases. It will explain in the short of code. So we can write the code in some less lines, and also it look like so pretty good. So if we see this factorial question, so there is no there is no need of that much logic to build. So let me explain what factorial is also. See, so 5 factorial is equals to 5 into 4 into 3 into 2 into 1. So this is the actual thing. Then what is the factorial of 5 in the term of recursion? 5 into 4 factorial. See exactly. So we can call a function by itself. Like, see, I'm calculating a factorial of 5. To calculate the factorial of 5, we need to calculate factorial of 4. So similarly, to calculate the factorial of 4, we need to calculate factorial of 3. So this goes on, and finally factorial of 1 is equals to 1 into factorial of 0. So here comes the major confusion. So the factorial of 0 is also 1. Yes, the factorial of 0 is 1. Also the factorial of 1 is also 1. So this is the way we'll calculate the recursion. Yes, this is the way we can implement the same thing in the recursion part. So let me explain with the example of factorial. Yes. So, see, yes, here is the code for the factorial. Yes, here is the code for the factorial, and also 5 factorial is equals to 5 into 4 into 3 into 2 into 1. So first I have taken this. Normally I am initializing the number, that is 8. So I want to find the factorial of 8. Okay, and then I'm storing my result as initially 0. So the result is factorial of the number. The factorial of the number is the factorial of 8. So I'm printing that factor system dot out the println result. The result is factorial of the num. The num is 8. So finally we have to find the factorial of 8. So now see, public static in fact int of num explains that we are creating a factorial function to find the factorial. So let me initialize a value as initial value as 1 for I for of. So I'm looping. So to complete this to complete this multiplication, so we have to loop from 1 to 5 now. So similarly we can write 5 factorial as 1 into 2 into, sorry, 1 into 2 into 3, 3 into 4 into 5. So we have to loop from 1 to 2, 1 to 2, 2 to 3, 4 to 5, like we have to loop from 1 to 5. Yes, see, int I is equals to 1 and I less than or equal to num. Yes, so once the I reaches to 5, so we have to stop. Yes, up to that we have to increment. So value is equals to value into I. So the first is I. First the number is 1, and then 1 into 1 is 1. Next 2, 2 into 1, 2, like that 2, and then 2 into 3, like that we have to increment the value. Then we have to returning the value. This value is the factorial of the number, that is 8, the factorial of 8. So if we run this one, so it is showing that something like a error. So I don't know, what is the error. One second, we'll run again. Yes, 40320. Let me show the another value, like a factorial of 5. Yes, the factorial of 5 is 120. So this is the normal method of finding the factorial. So let me show how we can do that in this recursion method. So see the how simple it is. Similarly in the previous case, same like that. I have initialized the factorial of function. So here see, if num equals to 0, return 1. So why? Because the factorial of 0 is what? The factorial of 0 is 1. So we have to return the actually. So if a person didn't know the concept of factorial, so he may think that factorial of 0 is 0. So for that case we are giving that factorial of 1 as if the number is 0, so return that as 1. So now return num into factorial of num minus 1. So here we are calling a function instead of a function. So exactly this is what the this is what the recursion means. So in this case, see how simple it was. So here it is having 26 lines, and here only 22 lines. So I have given the sum of the gaps. So if you reduce that, we'll get the number of lines will be decreased. Yes, decrease. So this is the concept of factorial with recursion and without recursion. So let me draw here. So what are the concept we have learned here? Recursion, sorry, factorial that is of with and without recursion. Yes. So far we have learned these terms. So now moving to the next topic. Okay, let me increase the font size. Yes. Now, next, what we are going to learn is finding the Fibonacci series using the recursion and without recursion. So let me explain what is the Fibonacci series. One second, guys. Yes. Yes. Oh, what is a Fibonacci? Like us, someone will call as a Fibonacci or a Fibonacci. So I'll pronounce like Fibonacci. Fibonacci series. So series starts with 0, 1, 1, 2, 3, and 5, 8, 13, 21, and so on. So guys, you may head of this see here actually. So the second one, the first and second are always fixed. Okay, first and second are always fixed, and the second and the third position will be the sum of the previous two positions, and the fourth position is sum of the previous two position. See here, so 2 is the sum of this 1 and 2, and also 3 is the sum of 2 plus 1 and 5. 3 plus 2 8, 3 plus 5 13, 8 plus 5 21, 8 plus 13. So this is the series. So if we draw the series like n is equals to n n is equals to, sorry guys, n plus, sorry, n minus 1 plus n minus 2. So can I say that exactly this is the series, so that is following in this Fibonacci? Yes, exactly. This was a series. It was following by the Fibonacci. Yeah, let me implement this. Let me show how can we implement this in this with this normal like the iteration, and like normally with this recursion. Yes. Yes, guys. See Fibonacci. Yes, I need the position like I need the eighth position. Like eighth position means this is the zeroth position, first position, second, third, fourth, fifth, sixth, seven, eight. So here eighth position is 21. Okay, and result is equals to Fibonacci of position. Yes, I'm storing the final result in the result variable. Okay, now get into the Fibonacci of of position function. Yes, the first one is 0, second one is 1. So C is the result. C is the result. Initially, I am taking it as a 0. Yes, the series is 0, 1, 1, 2. Now comes the logic. So if we are looping int I is equals to 2. Yes, the next one, though, so actually we have given the first two positions. The next one is from where we have to start, from second position. From second position, sorry, yes, from second position 0, 1, 2. 0, 1 position has been given, and we have to start from the second position. Yes, I less than or equal to position. So we need up to the positions value, and up to that we have to increment. So initially what I explained, C is equals to A plus B. Here C is equals to N, and A is the N minus 1 and B is the N minus 2. Yes, now if you see that, so we have to swap that value, because so here actually if we see here, yes, one second guys, uh, shapes, and not this. Yes, see guys, initially this was the B and this was the A. Now actually, so after that, now this becomes A and this becomes B. Yes, so definitely A has become B and B become the final result C. So finally, we have to return the value in the C. So then as usually, so return will be given to the Fibonacci of the position. So Fibonacci of the eighth position will be, as usual, what we need is 21. Yes, what I have said, the Fibonacci position of the uh, eighth position is 21. Yes, so what we need has been achieved. Yes, now let me show how we can do with this in recursion. Yes, how we can do this in recursion. See, same like this previously, So let me go back with the 8th position. Here, if the position is 0, make it as 0. If the position is 1 and 2, make it as 1. See, actually, if the position is 0, we have to keep 0. If the position is 1 and 2, we have to make it as 1. Same as the previous, we are making same in this recursion, and finally we are returning like a Fibonacci of position minus 1 plus position minus 2. So what exactly I have given here? See, n is equals to n minus 1 plus n minus 2. Similarly, same like that, we are giving position of n minus 1, Fibonacci of n minus 1 plus Fibonacci of n minus 2. Yes, yes, guys, have you understood everything? So this is the concept of Fibonacci in normal way, normal iteration, as like normal looping, and then in the case of recursion. So guys, let me like um, okay, let me ask something to you. Yes. So, mm, so Fibonacci series of to calculate the Fibonacci of eighth position, what we have to calculate is Fibonacci position of a 7 plus Fibonacci of 6. Yes, yes, yes. Then for Fibonacci of 7, we have to calculate Fibonacci of 6 plus Fibonacci of 5. Yes. Similarly, for Fibonacci of 6, we have to calculate Fibonacci of 5 plus Fibonacci of 4. Okay. Same like this. 1 second, guys. Let me enlarge this. Hmm. Yeah, that is fine. Yes. Now to calculate Fibonacci of 6, again we have to calculate for 5 plus 4, and then same for 5 we need 4 plus 3. So sorry, 4 plus 3. See guys, so this is my question. This is my question, guys. So here in the Fibonacci of in the calculating Fibonacci of 8, so here this was 1 second. Yeah, Fibonacci of 5 comes like 1, 2, 3 times. Yeah, see, Fibonacci of 5 comes 3 times. Like that, we have to calculate Fibonacci of 5 here 5 times. Sorry, 3 times in this calculation of Fibonacci of 8th position. So here comes the biggest problem. So here the space complexity and the time complexity will be increased. So space complexity will be high, and also time complexity will also be high. So to reduce this issue, so we are implementing the new concept as uh, we are implementing the new memoization. So this is the superhero of this what do you call that one session. So what it will do is it will store the values and uses whenever it comes again in the calculation of the factorial, or it may be Fibonacci, or it may be anything. Yes. So this is the concept of this is the main motive of this Fibonacci concept. So it will store the values, and it will uses, so whenever it is needed. Yes, exactly. So what is the thing, what is the happening is, so this will store the values whenever it is needed. Now how it will store is by calculating the, yes, well, let me show, by by mapping the values to the keys. Yeah, so this is the exactly like similar to the dictionaries in Python. Yes, yes, someone may be aware of this dictionaries concept. So this memorization concept is exactly similar to the uh, not exactly similar, like these keys and values for the particular key value will be stored. So let me walk through to the code for this memoization. Yes. See guys, same like the recursion code. So the newly introduced part is private static map. So the thing is, here we are using integer and integer. So I am creating a catchy memory. So temporarily, my all the values will be stored in the catchy memory, and then that will be retrieved. That will be retrieved from the catchy memory. So this is called as mapping concept. It's called as hash map. So for this one, we have to import two packages. That is import java.util.hashmap and import java.util.map. Yes, exactly, guys. So here that. So here I'm storing this Fibonacci in the result. I'm returning the result. See, in between the result and the returning part. So I'm keeping catchy dot put position comma result. So if already my position like Fibonacci of 5 is already calculated, so no need to calculate. Please use this value. So then the space complexity or the time complexity on the memory that is used will be reduced. So please use this like a catchy memories data. Yes. So this is what the concept of memoization. So guys, up until now, so what we learned is, uh, let me Fibonacci Fibonacci with and without recursion and memoization and Fibonacci with memoization. Exactly, guys. Today, what we have learned is, so these are all the topics. These are all the topics which we have learned today. Yes, that is this memoization concept is the like it is a part of an interview question also. Yes, guys. So this is the thing what we have uh, learned today. So let me solve the assignment problem, which is the we have to build the Pascal's triangle. Yes. So let me show you what is the Pascal's triangle. Yeah. See. Let me draw. uh, what is this? Yes. Let me draw this Pascal's triangle. Pascal's triangle. Yes. Now Pascal's triangle. How it will look like is, that is like a one, and then one, one. Similarly, one, and it is a two, one. Similarly, one, three, three, one. Yes, one, four, six, three. Sorry, four, one. Yeah, guys. You may understand this. Wait 1 second. Yeah, yeah. See, so what exactly Pascal's triangle means? So, see, guys. 1 second. Let me elaborate this. Yeah, yeah. This was somewhat okay. not a problem. Yeah, somewhat. Yeah. Okay. Okay. Then. So what exactly Pascal triangle means? So. mm let me yes let me take this. All right, so here this is the row one, first row, and this will be the second row, third row, fourth row, fifth row. So in each rows, the each rows, so here is the row number one, we are having only one column, and the row number two, we are having two columns, row number three, three columns, row number four, four columns. The first thing we have to note here is how many, like there will be number of rows is equals to number of, so the row number is equals to the columns, number of columns. Yes. Now just one, and also here it will be 0 and also 0. So how here 1 came means 0 plus 1, similarly 0 plus 1. So here how it 2 came, 1 plus 1, and then so the one will be same for the for row, like the start symbol of the row and the end element of the row will be 1, and then in middle, so in the outer triangle there will be no change, the all there will be the ones only, and the inner triangle only this will have the sum of the upper two elements. So 3, so 3 how come means 1 plus 2, and then 3, then 4, 1 plus 4, 6, 3 plus 3, 4, 3 plus 1. So the one will be common. So the thing is, the assignment is, so we have to calculate this Pascal's triangle is through three steps: iteration, I, iteration and recursion, and also the memoization. Very simple, guys, very simple. So if we understand the approach, so this is very simple, very simple. Yes. Now let me explain the code. So assignment one, yes, let me explain starting with the iteration. So guys, so I'll give this code in my in the video of this description. So anyone can see and anyone can so download this one, they can they can view this one. Yes. Yes, guys. Now I'm create, so now I need my triangle from row 1 to row 5. So that's why I have given the number of rows as 5. Yes. Now we have to initialize a two-dimensional array. So why we have to initialize two-dimensional array means, so there has then rows and the columns, there completely both of them are present. That's why we have to initialize the two-dimensional array, not one-dimensional array. Yes, I'm initializing as Pascal's triangle, that is equals to new integer of rows. Yes, rows. So the number of rows will be the, so the rows number what we are going to give. So now first we have to loop to the each row, that is of int I, and then I less than or equal to rows, and we have to increment. So now actually what I'm going to do is, so creating a array, so creating a array of rows. Yes, the starting will be 0, and then I'm incrementing to the uh, like 1, I plus 1, I is 0, so and then 1. Yes, starting will be 1, and then we have to create the columns also. Now column same for the number of rows, the columns will be given. Yes. So now as I explained, the first element and the last element of the row will be 1. Yes. So if j is equals to 0 and j is equals to I, so I means the end element of the row, yes, is equals to 1. I am initializing them to the, so their value as 0, sorry, 1. And then for the remaining elements, so the value will be the upper, like some of the previous one. So some of the previous, like a previous row, I minus mean previous row, j minus mean the exactly the number beside, and the j means the same number, like what I've explained in this 1 second. Let me, so for the three we have to, this is the I minus 1 and j minus 1. So this is the I minus 1 and j. Yeah, yes, exactly. So this is the logic, we need. and also for to display we have to loop, and also I'm printing the Pascal triangle. So guys, please remember, please, this is an so important. I am not printing as print ln. Why? Because I don't need my every value in the new line. I need only in my single line. The row will be in single line. Yes, single row. I have to print the each line, and after the each column, sorry, yeah, yes, each row I need to print that in the new line. So that's why print ln. So here I don't need the each row value in the single line, sorry, different line. So that's why I'm printing only print, and then I need the each row will be in the second line, the line wise. So that's why I'm printing the print ln. Yes, so this was the code, guys. Yes, see, I have given the number of rows as 5. So let me give the number of rows as 14. Yes, see, whatever the thing I am giving, it is printing the Pascal's triangle. Yes, guys. So this is using iteration. So let me explain how we can do with this recursion. Yes, how we can do with recursion means simply as a so based on this one, we have to loop. So firstly we have to loop. So we am creating a Pascal's triangle. I'm creating a Pascal's triangles. What we call that one, function. So in the function what I'm doing is, so here as usual I'm providing first and last elements of the row as one. Yes, first and last of the element of the row as. So else that I help to calculate the recursive part. Yes, we have to calculate the recursive part now, like Pascal triangle of I minus one comma j minus one and I minus one comma one, as I have shown in the previous part. Yes, Pascal triangle, the value of I minus one and the j minus one, I minus one and the j minus one column. Yes, sorry, yes, column and row. Yes. So here this is the logic to find the recursion. Yes. If we print the number of rows as 6, so it will print like this one. And similarly we have to do with memoization. Exactly, guys. So if you are able to find the logic and do with the iteration, recursion is very simple. And if you are able to do the recursion, memoization is very simple. Simply we have to import the packages, and also we have to create the catchy, so catchy hash map. And also we have to store our result in the, so we have to store our output in the result. And also we have to mention this catchy dot put I comma result. So why I have put the I means, so here it is the rows. So the rows means I, in my condition row means I. That's why I have given catchy for the I key, keep the result. So returning the result, it gives exactly the so value. So let me show. So up to 16, I have asked the Pascal's triangle. So it is giving the Pascal's triangle. Yes, guys. So this is the session about this recursion and memoization clearly. So the assignment is finding the Pascal's triangle. So this is using this normal iteration. And then this is the code for this recursion. And also this is the code for memoization. Yes, guys. Hope you have understood this. So completely we have learned exactly today. Oh, sorry. Yes, today we have learned these three topics. One is of a recursion, factorial with and without recursion, Fibonacci with and without recursion, memoization with and without recursion. So finally, guys, so what I used to say is, so please follow this challenges and telescope channel. So that you can know the something uh, what you call the interview question, and also some of the newly releasing contents like that it will be very nice. So winning the challenge is not an important. So being consistent with this 10 days is important. So this is my explanation. So that's all for today, guys.